thanks for everyone who's just joined. We've just started, so I've just been going through sort of a bit of an introduction. Just to recap, this is sponsored by DevHub North. They're a new community for developers in the north of England, and this is the first in a series of webinars which they're going to announce on their Twitter feed. So keep an eye on that over the coming months. So a little sound bite before we start, and this is maybe a little bit contentious, but this is kind of the approach that I take. I would rather rewrite over refactor, and we'll talk a little bit more about that a little later on, but I want to leave you with that, just mulling around in your heads as we're going through the webinar, and then we'll talk about that towards the end. So rewrite over refactor. So let's talk about a quick case study. So I've come up with kind of an offering. It's an event aggregator. So say, for example, you like to attend certain seminars and things like that by people that you like to watch speak, you know, whether that's Brian Cox or Richard Dawkins or whoever, really. But you don't want to kind of go to their websites all the time and try and find out when something's coming up and things like that. So the event aggregator is a service which will allow you to register your interest in a particular speaker. It will then automatically go to their events website and pull down all the events and do some kind of logic on those events to find the events that are near to you, so within the same country, maybe even the same city. And then it would present all of that on a single, through a single service, so a single page. And it would show all the events that are coming up that might be of interest to you. And that could be done through like a push notification, an email notification, or anything like that, really. So that's kind of the general idea of the case study. And it's what I'm going to use throughout this webinar to talk about some of the things that we're going to talk about. Okay, so let's move on to the first one, and then I think we'll start to get the gist of how things are going to go. So let's talk about something that's ideal. I remember a while ago I was watching someone speak, and there was this presentation, and there was this box, and there was loads of little boxes inside it, and then there was another box that got added, and then some of the other boxes got added as well, and there was lots of boxes suddenly appearing on this screen. And what they were trying to say was, you can just scale on the fly, you know, easy as pie. That's an ideal thing that we're kind of sold about microservices. You know, easy to scale whenever we need them to. You know, if we see that there's demand for a particular part of the system, then we can scale the service around that to match the demand and meet the demand. Equally, if we know that we see a spike in traffic around a certain time of day, you know, a certain time of year, I imagine that Christmas is a big time for a lot of online retailers. So, you know, if they were following microservice architecture, the idea is that they could scale up their payment processing service, or their checkout service, or just their general website, so that there's more servers, they're able to serve more traffic. And then once the peak period's over, then they're able to just scale back down to what's required and save some money through the rest of the year, and not face the embarrassment during that high peak period of having the website go down because of excessive traffic. So here you can see we've got the event source registration, and the idea is that you know, lots of people are suddenly registering events that they're interested in, and so what we do is we just be able to scale that. That's the ideal anyway. It's quite an interesting ideal, this one. It's got some interesting side effects that we're going to talk about in a little bit. So another ideal is this idea of complete code isolation. Everything's completely separated. All of your logic is separate and split into distinct pieces. You know, there's no kind of domain bleed or anything like that. You've got no dependencies between them. Everything's nice and shiny. And everything works completely independently. So that's another dream another ideal which is sold to us and we're told about with microservices. Again, this has got it's a bit of a double-edged sword, this one, because actually to think about complete code isolation, it requires a lot of discipline. And as we're going to see in a little bit, we'll see that it doesn't always work out this way. And we've got to be very vigilant to keep code isolated. Having your code isolated is definitely a good thing. Keeping your microservices nice and discrete without any domain overlap is definitely something to aim for. But how you aim for that can lead you down sort of dark holes that you don't want to go down that end up making the architecture really messy, which we'll see shortly. So something else which we're told, and this is kind of the same as the scaling on demand, is the update and deploy one component. So the idea here is, say for example, with the event scraper, if we come up with a new algorithm or a new way of scraping a certain type of website, depending on how it's structured or anything like that, then we don't want to have to redeploy everything. We just want to redeploy that single component, that one thing that we actually care about, and leave everything else working. Obviously, any time that we do a deployment and an update, it carries a level of risk. It carries a level of risk that things are going to break or things are going to behave in an unexpected way. And the thing that we don't want is to suddenly find ourselves where we've brought down the entire system because of something unexpected. So by isolating what we deploy, we help protect ourselves from this risk. Again, this is an interesting one. You're going to find that as I go through each of these ideals, it's always kind of ended with a, but this is an interesting one. There's something not quite right here that we need to be aware of. Let's talk about another one. So simple architecture. Simple architecture is like the holy grail of all of this. You know, it's nice and clean. You can look at a really simple diagram and everything makes sense. I mean, this diagram in front of you, you know, it's relatively simple. It's very straightforward. There's nothing really overly complex going on there. And that's really good. I think in a lot of other systems, you know, you can have very complex architecture, you know, N-tier architecture where it starts off as 3-tier and then it's 4-tier and then it's 5-tier, and suddenly you've got some other things going on and you've had to bolt something onto the front end because you've created a different kind of front end to serve mobile users, and you're having to bolt a REST API on top of it, on all kinds of things like that. And the idea behind microservices, it's trying to solve some of those problems to simplify the architecture into a way that's intuitive. And this one's a great one. All the languages, I think this is one of the big ones that's sold to a lot of people, is, you know, we can build each of the microservices in any language that we like, you know, C#, .NET for one, Java for another, Python for another. We can even have different databases and everything's nice and rosy, and you know, developers can work in the languages of their choice. They're not constrained to a specific language. And yes, technically that's true. But as we're going to see shortly, it's this ideal is difficult to achieve. So let's actually, now that we've kind of done a very high level gloss over of some of the ideals of microservices, we're going to talk about some of the realities of microservices now. But before we do, it is worthwhile talking about why microservices are such a positive thing to do. All of the ideals that we've talked about are genuine value-adding ideals. They make the life of the developer, the tester, DevOps, SysOps, you know, the whole range of people in the team and the business. It makes their lives so much easier. The realities, as you're going to see shortly, are typically from trying to achieve each of these ideals in a specific way and somehow failing to appreciate the bigger picture. So we're going to move into the first reality now, and this is quite an interesting reality. So let's talk about bottlenecks, backpressure, and flooding. So if we think about that first ideal that we were talking about, so scaling on demand, in a theoretical sense, that sounds fantastic. The danger comes when we fail to appreciate downstream dependencies. So in this example, we've got a series of event source registration services, all feeding thousands and thousands of messages into this message bus. So they're just putting, maybe it's just some JSON or something like that, but it's putting a load of data into this message bus, separate events. And then those messages are being picked up by both the event scraper and the event service. Now, what we see happening in this diagram is we see that the message bus is starting to struggle. And the reason why it's starting to struggle is that as we scaled the event source registration, we didn't scale the event service or the event scraper. And what we found there is that their capacities are not enough to deal with the excess demand coming from the event source registration. So this is putting some back pressure on the message bus, which is causing the events to build up and the message bus to start to fall over and fail. And this is a very real thing. So RabbitMQ is a very common message bus. RabbitMQ isn't built to handle messages sticking around for a very, very long time. It's built to deal with flow. It's built to take a message in and broadcast that message to various subscribers and consumers. Which means that when things can't consume from it fast enough, then it starts to use up its RAM. It starts to use up the disk, especially if you've got kind of the config set such that it's writing all the messages to disk so that you don't lose the messages and you can recover it from an outage. Which in turn is meaning that the system's not actually able to operate correctly. We can see that the event scraper is starting to fall over. It's not able to operate at all. The event services, it's kind of okay, but you know, it's struggling. And this is a very real phenomena. And what this is kind of an indicator of is the fact that we've not necessarily tuned our system to understand how it's going to behave under specific loads. So one of the things that we can do to remedy this is, you know, to actually do load testing, performance testing, and make sure we understand the performance profile. One of the things that we've kind of been sold with microservices is isolation. Well, it's quite clear here that where we thought we had isolation, and yes, we do, the code is isolated, the services are isolated, but actually there is a strong dependency between the services through this single point of failure, which is the message bus. So it's this kind of thing that we can kind of find ourselves falling into the trap of missing when it comes to implementing microservices. And suddenly You know, you start to, when you're in one of these situations where you're facing a potential outage and suddenly everything's starting to fail, you start to ask the question in the back of your head, am I really getting any benefit from this? Wouldn't I just have been better with a monolith? And it's a valid question to ask oneself. So this is a fascinating one. I love this one because it really highlights the importance of understanding the performance of the system as a whole, rather than just individual services in isolation. Let's talk about another one. So one of the realities that we've kind of been told about is this whole kind of, we only have to update and deploy a single service at a time. Well, that's not really the case. So we've got a relatively simple change here. We're just adding a new data field to our message, which is being passed around this system. Relatively simple change. You know, you'd kind of think, I'm just adding a single data field. Why won't it deal with that? And do we find that suddenly we've got to make a change in pretty much every single service? Now, I don't know about you, but that to me isn't having simple deployments and isolated deployments. That's suddenly a big headache to do. And this relatively simple change, you know, you could argue that in a monolithic application, this change would be easy because it's changing maybe 2 or 3 files and then deploying just a single service. Whereas here, you know, we've got a 3 database changes, we've got and 3 service changes. That's suddenly a very, very big deployment for a very small change. And considering that with each of these deployments, I mean, maybe you could isolate each deployment so you're only doing the event source registration and its associated DB change first, and then maybe the event service and its associated DB and so on. But that's still a lot of risk that we've suddenly found ourselves exposed to because of this microservice architecture. So we need to figure out a way of solving that, really. Typically the reason why this kind of thing occurs, where we find ourselves kind of constrained like this, is we've sometimes been too specific with what we're looking to kind of consume, and we need to stop being so specific. We need to, so for example, in the event service, we actually just need to identify the specific fields that we're interested in, and for everything else, we could just put them into a map, say, of strings to objects. And that would help us to deal with any time that we introduce a new data field. The data's still there, and it could be stored in the database using a similar construct, especially if you're using a NoSQL solution, such as Cassandra, Mongo, Dynamo, whatever it is, where we can store just maybe the raw JSON as is, and when we care about it, then we unmarshal it from the JSON object. Otherwise, we just kind of leave it in and let it flow through in a way that we don't care about it. So this is a big one that can really catch you out. And if you don't plan for this from the start, then it becomes significantly harder to change it later on. So it is worthwhile being aware of that. Now, there are some solutions to this which a lot of people kind of find themselves falling into the trap of, and handily it's the next reality. Templates and libraries. Oh, these are just awful. they're really, really terrible. And I'll tell you for why. If you have a shared library, it provides, it does several things. First of all, it's binding all of your services to a single separate library, which I think, you know, in a monolithic sense, maybe that makes sense. In a microservice sense, it really doesn't, because what happens is if you make a change to that library, you add a field. You maybe change the version of that library used in the event source registration, but you don't change that version in, say, the event scraper. So suddenly you've got two services which are using two different versions of this library. Now, this represents a real problem, because that library, as time goes by, that change, that difference is going to increase to a point where you're going to make what seems like an innocent change in that library, and suddenly your event scraper is going to fall over. It's not going to work because of the messages that are going through, typically through changing a data type of a field. You know, so changing, I don't know, something from, you know, taking an integer and converting it into a string, because you've realized that when you did it at the start, you put it as an integer, but actually you're not doing any mathematics on it, so it's better as a string because it's more representative of what it is. That poses a real problem, because suddenly the data that's going onto the message bus is no longer in a form that the event scraper can handle. Depending on the levels of validation that you've got around that as well, that can cause real issues and make everything very, very fragile and very brittle. And then the next thing that will happen, and this is beautiful when this happens, because it really hammers home some of the issues with templates and libraries. You start to put innocent business logic into that library, except that each of those services needs to do something slightly different. And then you start to put in some of the, well, what's calling me into that library. And before long, that library starts to become very bloated, very unstable and unusable. You know, if you come to read it, you're sat there wondering what's going on, because there's so many edge cases put into that library for various reasons that it's no longer serving a purpose. And you end up finding that instead of having three things to change when you add a single field, because you've done it through a library, you find that the changes required in each of those things is more significant. The levels of risk that you expose yourself to are more significant, because you know, when you put it into into production, weird things could start to happen. But it also sets a precedent as well. And you'll find yourself suddenly sitting at your computer looking at your IDE, and you'll see that you've got about 20 different custom libraries that you've built, and you're trying to add a piece of logic somewhere, and you know that it doesn't exist in the microservice that you've been working on because it was pulled out into that library because we were following some rules about not repeating ourselves. But you don't know which one because it's a bit obfuscated. And it suddenly turns a relatively straightforward task into more of a treasure hunt to find what's going on and to add in the change, and then eventually figure out that if I make that change, it's going to break all the other services, because it does. Or the best one is that you do it in such a way that you're able to just deploy it for one service, and then you've got to revert it for the other services, and you end up playing this version tic-tac-toe where you add the change, remove the change, add the change, remove the change, along with various other changes. And at that point, the outlook starts to look pretty bleak, to say the least. It's worthwhile mentioning that. So everything that I'm going through now, they're all hard-earned experiences for me. All of these realities I've experienced firsthand, and I can tell you that they really are not a joy to work with. They're very, very difficult, and changing them, as soon as you get into some of these realities, changing some of these realities is very difficult, because you've got so many side effects that you're not aware of, and that you can't anticipate. That it trying to change it turns into months and months of refactoring work, just to try and get it working correctly, and to simplify the architecture. So these rabbit holes are almost, once you go, they're almost like black holes, really. As soon as you start to go into them, if you don't get yourself out quick, you're in there forever, and you've got to deal with that. Let's look at another one. So one of the realities we were told about was this: use whatever language that you want. And that's a good thing, but the reality is that your continuous integration and continuous deployment tooling is typically built to just handle a single language. The people who are building the CI/CD stuff, if that's all been centralized, and it is in a lot of places, then it can be difficult to impossible to add support for new languages, and the type of config that you've got in that CI/CD tool stack becomes very complicated. If you think of Java, for example, with Java you've got maybe you're using Maven for all your dependency management, or maybe you're using Gradle, or maybe you've got one service that uses Maven and one service that uses Gradle. And so suddenly you've got to manage support for both Maven and Gradle. One service is using Java 1.7, the other's using Java 1.9. So we've got two different versions of Java. And this is just a single language, by the way. This is just Java. That's before we even get into C#.NET. And suddenly, so the complexity around managing those different versions is significant. That's not trivial. Then when we add C#.NET, well, what are we talking about there? Are we talking about .NET Framework 4.5? Are we talking about .NET Core 2.0? Or maybe it's .NET Core 1.0 or something like that, where we've gone from the JSON build file back into the standard CS proj on .NET Core 2.0, the various .NET Framework dependencies. And if you're just looking at .NET Framework, legacy .NET Framework, then you're no longer able to operate on a Unix system. You're onto Windows. So the Unix systems that you used in order to build the Java projects, which you had a load of config for to deal with the different build systems there, you've now got to support a completely separate and different operating system in order to support C#.NET. Plus whatever else comes in with Python, Python 2 versus Python 3. I think you can start to appreciate some of the hassle that comes about from that kind of flexibility. And that's a very difficult problem to solve. I think there is a simple solution, but the simple solution is usually to not have centralized CI/CD. It's to make each team deal with its own continuous integration and continuous deployment. But then you've still got to worry about things like, well, what are we deploying to? If we're deploying to the cloud, are we, say it's AWS, Amazon Web Services, for example, are we deploying onto EC2 instances, or are we deploying as a Docker container? So we've still got problems and things to worry about there. I think I've probably talked about that a lot at the moment. Let's talk about another problem. another reality. Shared databases. Oh, this one's lovely. So this is a serious sin of microservices. So we've looked at the libraries issue and we've looked at the simple change issue, and we've thought, well, it wouldn't be a problem if we just use the same database. You know, we'll just start looking at the same data and the same tables in the same key space, and then we've got access to all the data. Or maybe it's a cost-cutting measure of, oh, we don't want to pay for an extra terabyte of storage with all the redundancy that goes with that. This is a big problem, because as soon as you make a change to that database, you change that schema for whatever reason, and it does happen. As the business evolves and as the product changes, in order to stay competitive, the form of the underlying data will inevitably have to change at some point. So it's a given. It is going to change, and to say that it won't is kind of, it's burying your head in the sand a little bit to the realities of the fact that things will change, and you've got to be able to deal with that. So when we make a change to the database, you know, we make it so that maybe we've made a change to the database and the event source registration. Well, as we've done that, everything else has failed because it can't support the new schema. Let's look at another one. So let's talk about when something fails, when a test fails. Okay, it's something that I like to call, it's a triage hide and seek. Okay, something's failed and you don't know why, and you've got to hunt around however many microservices that you've got to try and figure out which component was it that failed. That can take a lot of time. That's a lot of work to do. You can kind of have a guess and say, well, it's maybe this service because it's doing something in a certain way, but it's still very difficult to identify what is going on and what's gone wrong with that. So really, you know, you need to be very careful of that kind of test, fail, triage, hide and seek thing, because as soon as you split up your logic, if you're not careful, if you split up your logic across different services, that's what will happen, and you'll be sat there at your computer and you'll probably spend about 3 or 4 hours trying to find out where this thing failed before you can even figure out how to fix it. Ah, this one. This is probably like the biggest issue that happens, and it's if I had to, so this probably falls second in my list of hates. It's all these innocent hacks, and every single innocent hack, you know, where you've done something and it's, you know, that you shouldn't have done that, or it's not ideal, it's tactical rather than strategic. That's the phrase, that's the terminology that's used to justify these sometimes. We need to be tactical for this release and then we can be strategic. Well, let's have a bit of a reality check here. Strategic never happens if you've already gone tactical. It never gets to that point. Essentially, we start getting into the death by 1,000 cuts. Every single innocent hack seems harmless at face value. But when you combine them all together, what you end up with is a very fragmented code base and very fragmented services, logic not quite in the places it should be. And did you see that innocent hack in the event service, which has started to just cheekily speak to the event scraper's database? That's very naughty, because suddenly you've coupled the event scraper, the event scraper's database, and the event service together. And if you change that database for either of the event scraper or the event service, you're potentially going to break the other service that you weren't changing it for. This is like the prime issue that happens a lot. This is probably the most common reason why stuff gets out of control. So we've talked about some of the ideals. We've talked about some of the realities there. The ideals, we do want to strive for those. The realities, these are typically the things that either come about because we've not appreciated the full situation, such as the bottlenecks, or they've come about as a way to try and solve some of the problems, such as, adding a single additional data field into our message that gets passed around. So let's talk about some of the remedies that we can use and apply. So the first one I want to talk about is vertical slicing. So if you've not heard of this term before, it's a really powerful term. So you've got vertical slicing and you've got horizontal slicing. So typically in say, for example, 3-tier, N-tier architecture, that's typically done as horizontal slices. You've got a layer which speaks to your database. You've got a layer which is kind of your middleware, your domain. And then you've got your view layer, which is the REST API or something like that. Those are horizontal slices because they're dealing with specific components of the technical landscape. Vertical slicing, on the other hand, is ignoring the technical landscape for the most part and focusing on the key full business requirement and logic. So the best way to think about it is it's kind of a vertical slice probably has code which does a bit of the view, a bit of the domain, a bit of the database, a bit of speaking to the message bus, a bit of speaking to a third-party repository to get some information or something like that. A single vertical slice is something that will do all of that, but the singular thing that it will do is achieve a core piece of critical business value-adding functionality. And this is really powerful. So what you can see here is we've merged the event event registration service and just the event service, because really they were kind of the same thing. It's the single vertical slice there is, I want to be able to add an event to my list of events. Well, that is surely just an event service rather than a registration service and almost a view service to be able to query. So we can merge that into a single slice. This is really, really useful to help you to deal with the issues that can occur when it's not quite clear where some of the logic needs to go. So by thinking in this kind of vertical slicing mentality, this vertical business slicing mentality, we solve some of those problems and we remove some of the stimulus for introducing some of those reality type solutions that end up causing us pain. Something else that we can do is to kill custom frameworks. So a common thing that can happen, and this is kind of that templates and libraries thing, is we end up building a framework. We end up saying, well, all of our microservices must be built in the same way. They must all use, say, for example, I'm using Java here, Spring Boot, and a specific version of that. Well, maybe that's not appropriate. Maybe that's not right. But the other thing that happens when you kill the custom frameworks is you remove the inheriting of regressions or defects. A microservice is something that should be so easy to spin up and so easy to create from scratch that having a custom framework, especially a codified framework, so for example, having a series of interfaces and abstract classes which let you say implement some kind of design pattern for dealing with like the command pattern or something like that, or a factory pattern to get you certain commands. all that really does is it just makes your code more complex, and it produces an opportunity to have the same defect present in every single service which used that framework to start with. Or worse, the fact that once you identify there's a defect, you've suddenly got X number of other services to go back and fix, and you don't quite know which services were built with which framework version. And so, by removing custom frameworks and just promoting good, clean code practices, your code is likely to look similar as a symptom because everyone's following the same kind of clean code mentality. Everyone's thinking about making sure we don't do those innocent little hacks. Frameworks can be used as a way of trying to control that, but ultimately they fail to do so. Let's talk about another one. So no shared databases. We talked about shared databases as a remedy to maybe the additional field problem, but actually just duplicate the data. As soon as you've got a shared database, you have a hard dependency between the two services or three services or multiple services that use it. And that hard dependency is something that will cause your systems to fail. So do not share your databases, duplicate the database, okay? Duplicate the data. If you want to justify why that's okay, well, first of all, storage isn't as expensive as we think it is. And secondly, if the cost of duplicating it outweighs the value that duplicating it adds to the business, then it's probably worthwhile going back to the drawing board in the first place. Okay, so the value that you get from the microservice that's been implemented should significantly outweigh the cost of the additional storage of that database and even the cost of the additional license for the database software. And finally, don't duplicate business logic. So this really falls into that vertical slicing thing, okay? And it's got a bit of a weird, interesting caveat here. With vertical slicing, what we're really doing is we are bounding our domain for that particular value-adding feature. When we bound our domain, we make sure that we're not actually having to query other services in order to satisfy the business logic that's required within the service we're building. So everything that's required for the business logic should be within that vertical slice. And we shouldn't duplicate that business logic across multiple services, because as soon as we find ourselves in a position where we're maybe starting to duplicate the business logic in another microservice, well, the chances are actually that that other microservice should not be a separate microservice. It should those two microservices should probably be just one microservice, and your business logic and your bounded context of your domain should all be within that single microservice. So where are we now? We've talked about some of the ideals that we're kind of sold, scaling, code isolation, single thing to update and deploy, simple architecture, using whatever languages we want. Then we talked about the realities. We talked about bottlenecks, backpressure, flooding, all that kind of thing. We talked about the fact that a deployment, can fall into the not simple category, and we end up having to redeploy everything for a simple change. Talked about some of the problems with templates and libraries, some of the problems around the tooling, especially when we've got different languages on the go. We talked about the hard dependencies of shared databases, and we talked about the triage, hide and seek that we go through when something fails and we've got our logic split. And then lastly we talked about the innocent hacks, the simple innocent little things that seem harmless and then come back and bite us later on. And we've talked about some of the remedies to this. We've identified, well, if we have good strict vertical slicing, then we deal with that domain bleed, and we deal with the simple change thing. We don't need to have the templates and libraries. If we remove the frameworks, the custom frameworks that we try and mandate has to be in every single microservice, well, we deal with some of the problems and the inherited defects that come from that. By not sharing the databases, remove that hard dependency, and by not repeating our business logic and firmly defining our vertical slices, then we start to solve a lot of the big problems that hit us in the realities situation. You know, the test triage is suddenly very simple because we know all of our domain logic is in a single place. That business logic is in that single vertical slice inside that microservice. So let's start to wrap up. So microservices, they are hard to get right. They are difficult to get right, and they require discipline. The benefits are real, but in order to get those benefits of a nice, simple developer life, we have to put in some effort up front to make sure that we've got the right kind of team culture to actually do things in the right way, and that we also keep an eye out to proactively jump on some of the issues that we find ourselves with before they start to become blockers and serious pain points to the point where we can't deliver for the business anymore. Justify duplication cost by building value. Each vertical slice should be a value adding thing. And that's how we can justify that to the business. You know, a business might say, well, why aren't we just using the same database? Well, actually, you know, we can talk about some of the pain points that causes and some of the traps that puts us into, and the fact that it stops us from delivering for the business. So we can justify the duplication very, very easily. I mean, the cost of duplication is minuscule compared to the value that the microservice should add. Just rewrite it, don't refactor it. If you're refactoring it, chances are you're building a framework and you don't even know it. Your microservice, it should have a very clear bounded context. It should be well defined to the point where if something's not working with it, it is actually cheaper to just rewrite it, because it should be so simple that rewriting it, the cost of rewriting it is less than the cost of refactoring it, because the cost of refactoring it kind of starts to imply that there is more going on in there than should be going on in there. If you need to refactor it, it's because something's not quite right within there. And then lastly, this term dry, don't repeat yourself. This only applies to business logic. So many people apply it to technical components of their code, and suddenly you end up with a shared library and a template. Actually, it just applies to the business logic. Do not repeat your business logic. Technical bits, copy and paste that as much as you like, because they're not the bits that are going to cause you pain. If you start to remove the duplication of your technical bits, you start to meld different separate bits of business logic into one thing, and you end up having little edge cases in these utility methods, which need to start to know about the business context of the various bits that are calling it, which can be different. And suddenly you end up with your business domain starting to bleed into each other. Don't repeat your business logic. Feel free to repeat your technical components, because ultimately they don't matter. A computer is more than efficient enough to be able to deal with those, that little bit of duplication. So hopefully that's been useful and informative. I think there's a Q&A part on the webinar. Thank you so much for listening. If anyone does have any questions, then please feel free to ask in the chat or in the Q&A part.